In less than 5 minutes, the world's greatest power plant completely collapsed. Most people believed it would never operate again. Everyone saw a destroyed factory, but one engineer saw the beginning of something even greater. They called it impossible, but what happened next changed the future of engineering forever. Stay until the end.
At the heart of Titan Valley stood the largest Mac colony.
Inside the turbine hall, thousands of tons of precision machinery operated in perfect synchronization, converting steam.
Every second, millions centered on.
Deep inside the boiler complex, thousands of tons of steel and advanced automation transformed fuel into superheated. An enormous network of high-pressure steam pipelines carried thermal energy across the full efficiency. Each generator weighed hundreds of tons, producing enough electricity to supply entire regions while operating with extraordinary mechanical precision. Every second, millions of liters of cooling water circulated through the plant, protecting the turbines and generators while maintaining maximum operating efficiency. From this enormous substation, ultra-high voltage electricity pulled across mountains, rivers.
Deep inside Titan Valley, the National Grid and Control Center balanced electricity of kilometers of transmission line.
Artificial intelligence monitored millions of engineering parameters every second, allowing maintenance teams to detect problems long before equipment could fail. Everything appeared normal. Yet, beneath the factory floor, something had quietly begun to change, something no one could see.
Far beneath Titan Valley, sensitive seismic instruments detected a faint underground vibration.
Travis. The warning signs were becoming impossible to ignore. Deep below the factory, powerful geological forces. Far below the factory, the Earth itself was beginning to move. What started as microscopic movement was rapidly becoming a serious geological threat.
Emergency shutdown! Evacuate all non-essential personnel!
The earthquake reached the electrical heart of Titan Valley. Within seconds, the world's largest transformer yard erupted into a chain of catastrophic failures. In just a few devastating minutes, the greatest power station ever built went completely silent. The impossible had happened.
The failure spread across the international grid within minutes.
Entire city.
When daylight revealed the damage, even the world's most experienced engineers struggled to believe what they were seeing.
We are not rebuilding a factory, we are rebuilding hope. Most experts believe the facility should be abandoned.
Project Phoenix began with precision demolition. Every unstable structure had to be removed safely before rebuilding the world's greatest power station could begin. Millions of tons of damaged steel and concrete were carefully removed. Even during demolition, every material was cataloged for recycling and future construction. The new foundation would become the strongest ever built, designed to withstand earthquakes far more powerful than the one that destroyed the original facility. Every structural beam was manufactured with millimeter precision. The new power station would be stronger, smarter, and safer than ever before.
The heart of the power station had arrived. Every millimeter of alignment would determine the future performance of the world's largest turbine.
Surrounding the turbine, the enormous generator transformed mechanical energy into electricity with extraordinary precision and engineering excellence. The new ultra-supercritical boiler was engineered to deliver greater efficiency, lower emissions, and unmatched reliability for generations to come. An advanced cooling system would protect every turbine and generator, ensuring maximum efficiency under the most demanding operating conditions.
Events. Behind every megawatt of electricity stood an intelligent electrical network designed to deliver safe, stable things. Before a single turbine could be installed, its foundation had to be positioned with absolute precision. Precision always comes before speed. The turbine foundation was aligned 1 millimeter at a time until every measurement matched the engineering design. Every anchor bolt became part of the power station's future. Each one was tightened with carefully controlled force to guarantee decades of reliable operation.
Slowly, the massive turbine rotor settled into its bearings. Months of preparation had led to this single, carefully controlled installation.
Today marked one of the most important milestones of the project. The Metzen rotor was carefully lowered into position.
Before the turbine could begin operating, engineers carefully verified the bearing clearance. Every measurement confirmed the rotor was perfectly supported. Every lubrication pipe was installed with exceptional care. A reliable oil system would protect the turbine throughout its entire service life. With the foundation complete, engineers carefully installed the main lubrication oil pump. Every bolt was tightened with precision before the next stage could begin. The duplex oil filter would protect the turbine from microscopic contamination. Careful installation ensured long-term system reliability.
The oil cooler was carefully positioned to help maintain stable operating temperatures once the turbine entered service.
Engineers carefully connected the lubrication pipeline. Every flange was aligned and tightened with precision before the system could move forward.
The lubrication control valve was installed with great care. A smooth and reliable oil flow would be essential for protecting the turbine.
Before introducing lubricating oil, every mechanical connection was inspected one final time. Careful preparation prevents future problems. Before any electrical connections could begin, a strong cable support system had to be installed. Every section was carefully aligned and securely fastened. Installing high-voltage power cables required patience and precision. Every meter was guided carefully to protect the cable from unnecessary stress. With the cable securely supported, the electrical system was one step closer to completion. Careful inspection ensured the installation met the highest engineering standards.
The generator terminal box was carefully installed. It would later become the connection point between the generator and the electrical system. One careful connection at a time, the generator became part of the future power network.
Before electricity could flow, engineers verified the insulation of every power cable. Safety always came first. Small temperature sensors would continuously monitor the generator during operation. Careful installation ensured accurate readings for years to come.
Vibration sensors would help engineers detect even the smallest mechanical changes long before they became serious problems. Clear cable identification would make future maintenance faster, safer, and more reliable. The control panel was carefully installed. It would become the central point for monitoring and controlling the power plant. Each control cable was connected with care. Accurate wiring would ensure reliable communication throughout the entire power plant.
Every connection was inspected one final time. Careful verification ensured the control system was ready for future testing.
The PLC cabinet was installed with precision. It would become the digital brain of the power plant.
Reliable communication begins with careful installation. Every fiber optic cable was protected before the system came online. Each fiber optic connection was joined with exceptional precision to ensure reliable communication throughout the facility. The first SCADA equipment was installed with great care. It would soon become the digital center of the entire power station. Each industrial server was installed carefully to provide reliable monitoring and control for the future power plant. The network switch would allow every control system inside the plant to communicate safely and efficiently. The operator workstation was carefully prepared. Soon, it would become the place where every major system inside the power plant could be monitored. The display wall would soon provide a real-time view of every important system throughout the entire power station. For the first time since the disaster, the control room came back to life. It was a small step, but it marked the beginning of a new chapter. For the first time, the turbine moved under its own turning gear. The slow rotation allowed engineers to verify that every mechanical component was working smoothly.
Clean lubrication oil flowed through the turbine for the first time, protecting every rotating surface before full operation could begin. The cooling water system came online exactly as designed, preparing the plant for the next stage of commissioning.
The steam pipeline successfully passed its first pressure test. Every connection remained secure under carefully controlled conditions.
The main steam valve responded exactly as expected. Smooth operation was essential before the first turbine startup. The turbine completed its first slow rotation successfully. Months of careful engineering were beginning to come together. The excitation system responded exactly as expected. For the first time, the generator was ready to produce electrical power. The main transformer came to life with a steady electrical hum, bringing the power station one step closer to full operation. After months of careful work, the generator synchronized perfectly with the electrical grid. Every system was finally working together. For the first time since reconstruction began, the generator produced clean electrical power. Months of careful engineering had become reality. Electricity began flowing into the transmission network, marking another important milestone in the recovery of Titan Valley.
Electricity began flowing into the transmission network, marking another important milestone in the recovery of Titan Valley. Reliable electricity returned to one of the city's busiest hospitals, allowing critical medical services to continue without interruption. Stable electricity allowed factories to begin operating again, helping industries recover after months of reconstruction. As darkness fell, the city glowed once again. The rebuilt power station had fulfilled its purpose, bringing light back to millions of people. The rebuilt power station was now operating exactly as designed, delivering reliable energy with stability, efficiency, and confidence. Behind every successful machine stood the dedication of thousands of skilled engineers, technicians, and workers who never gave up. The greatest achievement was not rebuilding the factory. It was inspiring a new generation to dream, learn, and build an even better future.
The power station stood stronger than ever. Every challenge, every setback, and every legend. Great achievements are never built by machines alone. They are built by people with vision, knowledge,